Alright guys, I'm going to go through a few problems off the Chapter 7 review. Keep in mind you will have a test coming on Thursday, so if you have any questions on whatever I go over today, or if there were any questions on the review that you struggled with and you want to ask me about, now's the time. Give me a call, send me an email, whatever you want to do. I want to make sure you guys feel well prepared for this test. Again, that will be on Thursday. So I'm going to go through a few of the questions from the review that was on page 227 in your textbook. So I'm going to start with number 2. It says in 6y to the negative second, y to the negative second equals what? Okay, and your answer choices were negative y times negative y. You had 1 over y squared. You had 1 over the square root of y. Okay, so what you want to do is you want to remember what we learned with negative exponents. So how do we turn a negative exponent into a positive? Okay, now in order to do that, what we need to do is we need to take whatever that negative term is and we move that to the denominator of a fraction. Okay, so what we have is y to the negative second, and in order to make it positive, we need to move that y into the denominator of a fraction. Okay, that numerator is just going to be a 1 over y, okay, and we need to keep that exponent of a 2 around the whole term. Okay, so y to the negative second becomes 1 over y to the second, giving us an answer choice of B. Okay, so keep that in mind when we're doing negative exponents to positives. Okay, we move it to the denominator and that makes the exponent positive. Okay, so let's look at number 3. Okay, it says in the square root of a times the square root of b, okay, where a and b are both positive, what would this equal? Okay, we're multiplying 2 square roots. Okay, so all we have to do in this instance, almost as if they're parentheses, you just combine them under your radical. Okay, square root of a times the square root of b equals the square root of ab. Okay, no calculations can be done because we don't know what a or b are equal to. Okay, all right, I'm going to jump to number 8 now. Okay, it says the nth root of ab equals what? Okay, so remember, when we're rewriting radical expressions with exponents, that exponent is going to be a fraction. Okay, and that's what this question is asking us to do. It's asking us to rewrite this problem that we're given with a fraction as the exponent. Okay, so remember, in order to do that, we need to say what's the exponent on the inside of the radical. Now we don't see one, so we assume that there's just a 1, right? Okay, whatever exponent is on the inside, that's your numerator for your exponential fraction. Okay, whatever's on the outside, this is your root index, that becomes your denominator. So the terms on the inside stay exactly the same. Okay, and remember, this 1 is now your numerator and this n is the denominator for your fraction. So I believe that comes out to answer choice B for number 8. Okay, remember, exponent on the inside is your numerator, exponent on the outside of your radical or your root index, that's your denominator. Okay, all right, I'm gonna flip over. I'm gonna do number 10 now. This section is multiplying and dividing expressions, and your answers should be written in terms of positive exponents. Okay, so what it gives us is m plus n to the negative 6th, okay, times m plus n to the 3rd. Now, remember, these bases are the same. So, with our exponents, we're going to add. Okay, so negative 6 plus 3 gives us m plus n to the negative third. Okay, now, this is not our final answer. Remember, the problem tells us to write our answer in terms of positive exponents, okay? So, back to our negative exponents to positive, all we need to do is take this term, and we're going to write it in the denominator of our fraction, okay? So this then becomes 1 over m plus n to the third. And that's all you have to do for this one. So all we did was we combined the exponents, which left us with a negative, which we then needed to turn positive by placing it in the denominator of a fraction. Okay? Alright, I'm going to jump to number 15. This section says, complete the operation, give your answer in radical and fractional form if appropriate. Okay, so number 15, it's the cubed root of x cubed over y to the 6th. Okay, so all we need to do is simplify. So we're going to look at this as two terms. We have x cubed and we have y to the 6th. So if we take the cubed root of x cubed, remember this root and this exponent, they're the same number, right? That means they're able to cancel each other out. They are opposites, a cube and a root. So in our numerator then, the cubed root of x cubed leaves us with just x, okay? Now in the denominator we have y to the 6th, and we're finding the cubed root of that. So all we have to do is divide. We're going to do 6 divided by 3, which gives us y to the 2nd. Now, because x and y are differing variables, they are unlike terms, we cannot combine, which means this is in its simplest form. Okay? Now, I'm going to put 16 down here as well. We have the 4th root of x plus 3 times the 4th root of x. Okay, so the only difference between these two terms are their coefficients. Remember, the coefficient is the term that comes before whatever your variable is. Okay, so with these types of equations, as long as your radical matches 4th root of x and the 4th root of x, all you have to do is add your coefficients. So we don't see a coefficient for this term, but we can assume that there's an invisible 1. Okay, so if we're just going to add them, 1 plus 3 gives us 4, and your root stays exactly the same. So it's 4 times the 4th root of x. Okay, and that is as simplified as you can go. Okay, so let's look at number 18. Okay, it is the cubed root of 2 cubed times the cubed root of xy. Okay, now same as up here in this problem for number 15. Remember, the cubed root and the cube cancel each other out. The same thing happens here, the cubed root of 2 cubed. So what that leaves us with is just 2. Okay, now we don't know what x and y are, and all we know is that we can assume that they have exponents of 1, right? So what we're going to do is we're going to change this from being inside of a radical to having that fractional exponent. So remember, whatever the exponent is on the inside becomes your numerator, and your root index becomes your denominator. So your terms on the inside stay the same, xy, okay? And then your fractional exponent is going to be 1 over your root index of 3, okay? And that is as simplified as that one goes. So it would be 2 times xy to the 1/3 power. Okay, so this is number 15, this is 16, and then this one here is 18. Okay, so I'm going to skip down to 21 now. This section just says to solve for the unknown. Okay, so all we're doing is solving for the variable. So 21.